Okay, welcome back. We're talking about how to iterate over an array list. This is kind of the crude way of doing it. Let me just run this. By the way, I changed the number of students to 5 so I don't spend that much real estate displaying this thing out. And go, there we go. So I have, my random number, my length, and only 5 students because otherwise it would have been too much. And then just Bob and Sally. Okay, cool. Now there's a better way to do that. And the better way to do that is to use this thing called an enhanced for loop. So where I say for, and then I tell string name, how about just string s, and then a colon, and then I say names, okay? And then when it comes time for me to display this stuff, I can just do this, and I just say s. Okay, now this it will display the same, right? No difference in how it displays. It's going to be absolutely identical with that regard. And ta-da, it's Bob and Sally and Bob and Sally. Okay, cool. But this thing is tremendously more efficient. Now, let me try to get into that. So, when using an enhanced for loop on an array or an array list, there are some significant disadvantages in doing it. One is, unlike this, I can go forwards and backwards, right? I mean, I can start at any number. I can start at number 5 and go to 7, or I can count by 2s, right? So, this guy is read only. I cannot make a change. Like, I can't, I didn't want it to be Bob. Let me fix that. No, sorry. So it's read only, it's forward only, and there's no skipping and jumping around. I can't like jump by 2s or something. So this guy has some significant limitations. The number one, the one that comes to mind a lot is I can't change the values in here. In here, I can go in here and say, wait a minute, I want to change name. The 5th one, I want to change it to, to Nancy. I'm sorry, can't do it using this guy. But it is significantly faster. Now let me explain why it's more efficient. Okay. If you know that you're always going to start at the beginning, and you're always going to increment by 1, and you're always going to, and there's no chance of you making any changes to any of these things, then I can cache this thing up. I can take the array and pull it all into memory so that when you ask for the first one, like here, when you're asked for the first one, while you're asking for number 1, it's going to turn right around and give you, and behind the scenes, it's going to go grab the value for the second one. And when you ask for the second one, it's going to go behind the scenes, it's going to go grab the value for the third one because it knows you're going to ask for the third one next. It can't do that here because it doesn't know if you're moving in the right order. I mean, you could be going backwards or you could be skipping over things. And so all 3 of those things, the thing that it's read-only, forward-only, and no skipping around, allows it to be cached. And so we're talking significantly more efficient. I mean by a lot, like hundreds of times faster when dealing with some things. Okay, so that was kind of cool, right? You might want to remember all that. Now, can I use an enhanced for loop anywhere I use a normal loop? I mean, can I just swap them out indiscriminately? No, I just told you. No. The for loop is going to be required for any time you're trying to change something or scoop or run forward or backwards or skip around, right? Okay, good. All right. On page 391, they start talking about polymorphism again. So polymorphism is, first of all, polymorphism is natively supported. That's kind of a poor choice of words. Natively supported by the array and the array list. The array and array list can take any type of item as long as it is inherited from. Now, let me get the example here of this array list guy. Okay, so I'm going to build me another array list. This time I'm going to build me an employee non-exempt guy. Whoop. Employee non-exempt. And I'm going to call him imp2. And he's going to be new employee non-exempt. And it's going to be, I don't know, Sally Jones. And she's going to work in the, let's put her in admin. Okay. Okay, so I've created me an employee exempt guy, and I'm going to add this to imp list add imp2, and it is not going to complain. Now, didn't I just say that the data type for this array list is just the plain old employee, and yet it didn't complain at all, which is kind of weird. Why? Because it supports polymorphism by itself, which means it'll take the data type you told it, or any data type that is inherited from that. Okay, so to make this make sense, I'm going to have to add some more stuff in here. So I'm going to say imp1, then I'm going to say, I'm going to do the set, the hours, and we're going to do 40 hours. And I'm going to have to do an imp1 set the pay, the rate. And let's just say they make $10 an hour just to make it easy. And then I'm just going to copy and paste this just because I'm lazy. Notice I did that before I added it to the array list, right? So this is going to be employee number 2. Employee number 2. Cool? All right. Actually, hold on. Let's do it differently. Let's make it 42 hours and 42 hours, because one of them is going to get overtime and one of them is not. They both get paid $10 an hour. Okay. So now that I have an array list that's been a fully populated employee and an employee non-exempt guy, then I'm going to go through and I'm going to use an enhanced for loop, because that's the most appropriate way to do this. So here we go. So I'm going to say for employee imp colon imp list. Okay, now once again, I'm using the lowest common denominator. I'm using employee because that's the base class for the other one. Okay, I could not have done this if I started with employee non-exempt. I have to use, like, if this is like a pyramid structure, I have to start at the top of the pyramid. So if there is an employee and an employee exempt, an employee salary, and an employee whatever, I need to start with the one at the top. So now I do this. Now I can just say et display append, and let's do something about this. Let's say employee number. I tell you what. Let's just do. Hang on. Let's just do imp toString, and then we'll do pay equals, and then I'll say imp.calcPay. Okay, now this is polymorphism. Why is it polymorphism? This demonstrates that I can take values and throw them into an array or an array list that are somehow related, and then when I ask it to do calcPay, it says, well, I know you told me that this was an employee. You told me that. But when it comes time for me to do calcPay, I'm going to see if there's a better version of calcPay. And ooh, when it comes time for the non-exempt employee, there is a better technique. The one that calculates the overtime. So let me fix this thing up so it doesn't mess up my display. Okay, so let's just run this to see what happens. Because they both get 42 hours and both get paid the same. So, right, we should be able to figure out that, yep, Bob gets $420 and Sally gets $430. Cool? All right, that's polymorphism. All right, I'm demonstrating polymorphism by using an array list and an enhanced for loop, and then asking it to figure out what version of calcPay should I use. Okay, that kind of makes sense? Whew. Okay, on page 393, they start talking about a hash map. This is kind of sort of similar to an array list, but it's in some other languages it's called a dictionary. Okay? So I'm going to do one, and I'm not going to spend too much time on it. Let me just show what I'm talking about. So I'm going to go in here and say I want a map, and I'm going to create one that's an integer and string combo. I know it looks a little funny, but just bear with me. And then what I'm going to call this thing, I'm going to call mine color map. Is equal to no. And then I'm going to say hash map And again, you could put all that stuff in there, or you could just cheat and do it like that. Okay? So what's going on here? Yeah, this is exactly the same thing we did with the array list. I can't use a primitive type, but I can do this, and then that'll make it shut up. Okay? Oh, well, obviously I need to import a class. Okay, everything cool? Now I can go in here and say I want to do a color map. Just pretend like it's an array list. So how did we do it before? Well, we did add, right? Except this case it's put. And so, I don't know, number 12 is blue. And then let's do another one. Color map. Put, I don't know, 42 is green or red or whatever, right? Okay. Now, so this is like a dictionary. So whenever I ask for 12, it'll tell me blue. Whenever I ask for 42, it'll tell me red. How useful is that in this scenario? This is a contrived scenario. So let's just do one for sure. I'm just going to say like string color is equal to, you know, whatever the color map is. Color map dot, you know, get number 12. Right? That's just how it works. Okay, not very exciting, but you can see how if you wanted like sort of like a database or lookup kind of a thing, where you could very quickly, you know, like translate. Okay, ooh, there's a good one. Translate between English and French. You'd have all the English words and French words, and whenever you asked for an English word, it would immediately spit out the French word for it. Okay, that's a good example. In the notes, it talks about how you can do an enhanced for loop with the entry set, and that'll display them all. Okay, kind of cool. All right. So the next thing we're going to do is we're going to move on from doing that to something completely different. And that is, now that I have an array list, imp list, I want to be able to save it when I do a device translation, right? You know, when I rotate the device, it wipes everything. I remember the bundle guy, right? All that good stuff. So from chapter 6, we created we had an on save instance state and an on restore instance state. And so, remember all that? Good. So, there's two basic choices on how you can store something complex like an imp list. Okay, that is kind of complex, right? It's got a lot of moving parts to it. One way is just to use what's called serialization. And this is the old technique. It's been around for quite some time. It's not that complicated. You could go in here and just say, you know, put serializable, and then send it on out. So it's very, very little you have to do. However, it is kind of slow and pokey. And so not too long ago, they released a second technique. And so the second technique is using something called parsable. I know it's a horrible term even to say. Something is parsable. So there's a parsable interface. And when I make it parsable, then it's a little bit more work to do because you have to tell it precisely what's in this thing, what's in the employee. You have to go in and say, well, it's this, and it's this, and it's this, and it's this. Now, that's a lot more work for you, but it's a heck of a lot faster because if you had to do the serialization, deserialization, when you rotate your device, it might go, hang on a second, oh, here it is. It takes a long time to serialize and deserialize. So we needed something that runs faster. So when you do a device rotation, your guy is right there, no time wasted at all. The problem is, to make it faster, it puts more of a burden on you, the programmer, to pull this off. Okay, so we're coming up on the 15-minute mark.